We're going to be dealing with 2.5. Now, 2.5, the title of the lesson is Transformations of Functions. So in the first example, we are going to identify the vertical shifts. So we have talked about vertical and horizontal shifts in 2.1. So right now we're going to talk a little bit more about them. So for the first example, let's say the original equation is y equals square root of x. And the equation they're going to give you, the one they want you to identify what the transformations are, y equals the square root of x plus 1. Because it is not grouped with the x, it is by itself. If you see a plus, it means it moves up. So the answer for this one would be up 1 unit. So for B, let's say the original function you get is y equals x squared. And then they want you to change this one to y equals x squared minus 3. Once again, we look at this. When you see a minus, because it is not grouped in parentheses, it means that it moves down. So my answer for this one would be down 3 units. So these are the two possibilities for your vertical shift. Is either up or down. If it's plus, it's up. If it's down, it's a minus. So let's look at example number 2. For example number 2, we will identify the horizontal, which means sideways, horizontal shifts. So the first problem we have here, the original equation will also be y equals square root of x. And they're going to ask you to compare it to the square root of x plus 3. Now here it is grouped. It is very different from the A and the first problem. So when you look at A, it's outside in example 1, but when you look at it here, it's inside, it is connected. So when it's inside with this group, it is a horizontal shift. When you see a plus, it's going to move left. So when I have to figure out the answer, it would be left 3 units. The original one is y equals x squared. Y equals parentheses x minus 4 squared. Once again, it is grouped. They're together. When you see a minus, we should know that it moves to the right. So my answer here would be right 4 units. So if you see a plus, it's left. If you see a minus, it's going to be right. Let's look at C. What happens if they give us, hey, we're going to do the cube root of x? And the problem I want for you to combine it or compare it to, it's the cube root of x plus 5. So if I see a plus, plus again means what? Left. So my answer here would be left 5 units. Y equals the absolute value of x. Y equals the absolute value of x minus 3. Once again, it's a minus 3. It is grouped together. Minus means right. So this means that this one moves right 3 units. So just to review, for the vertical, shifts, if it's a plus, it means up. If it's minus, it means down. For the horizontal, shift, if it's a plus, it moves left. If it's a minus, it moves right. So please keep this here in mind. This is what you need for both vertical and horizontal. So let's go ahead and move on to example number 3. In example number 3, it's going to be something a little bit different. We're going to identify the reflection, or if there is a stretch or a shrunk. Now, how do we do a stretch or a shrunk? Stretch or shrunk. Sometimes the stretch, we know it as it got narrow. And sometimes the shrunk, it is going to get wider. So we'll talk about that right now. So for the first example, or actually some information you need to know, before we do that, is that if A, and I'm going to show you where's A, is greater than 1, there is a stretch, or the graph got more narrow. If A is between 0 and 1, there is a shrunk, which means that the graph got wider. So what in the world does that honestly mean? So just to have an idea, when we have a graph, I'm going to say the stretch is going to be in pink and the shrunk is going to be in green. So let's just say this is the original graph. When something stretches, it's going to get skinnier, it's going to get more narrow. When something is shrunk, it's going to get wider. Sometimes we use the word fatter, but I don't like that word. So green shows a shrunk, the pink shows a stretch. So actually doing examples right now. Now the question is, where is A? If we're talking about the square root of x, A is going to be in front. If we're talking about the x squared, A is going to be up front. If we're talking about the absolute value, A is going to be up front. So it doesn't matter where it is, it's always going to be the first thing that you see. Now, for A, let's say they gave you y equals the square root of x, and then they changed this to y equals negative square root of x. So we have talked about the stretch, the shrunk, but if you look at here in the notes or in the title, we also mentioned the word reflection. So anytime that you see a negative or that your A is negative, there is a reflection. There is a reflection. Now the reflection is over the x-axis. So let's look at B right now. Let's say my original function is y equals x squared. We're going to change it to y equals negative 2x squared. So the question here is, what is new? This. Now, if that is new, first of all, when you see the negative, you should know there is a reflection. Looking at the number. So let's look at the number 2. If I look at the number 2, is the number 2 going to be greater than 1 or between 0 and 1? Because it is greater than 1, then there is a stretch. So this would be my answer for B. That's the answer for A. So once again, the 2, you don't care if it's a negative 2. You're just looking at the 2 because the negative already took care of the reflection. So 2 is greater than 1, so that's why it's a stretch. Let's look at C. Let's say we had y equals x squared, and now we're going to change it to y equals 1/2 x squared. So what is different up in the front? The 1/2. Because the 1/2 is between 0 and 1, then that should tell us that this graph just shrunk. It shrunk by 1/2. And that would be the word. By 1/2, and this one stretched by 2 because it's the number that they give you there. So let's try to do a combination of all the things we learned in example 1, example 2, and example 3. So let's try some DIYs. So let's look at the first one. We're going to go from y equals absolute value of x to y equals negative absolute value of x plus 1 minus 3. I always like to start from left to right. So let's look at this. So the first thing I see is a negative. Then I see a plus 1, and then I see a minus 3. So the negative should tell you that there is a reflection. This plus 1 here should tell you, because it's inside, it's grouped. Remember, this is your horizontal. That means when you remove sideways. And this one here is your vertical. So this is your horizontal, and that is your vertical. So when I see a plus, I should know that I am moving left 1 unit, sorry, because of the plus. This vertical, because it's a minus, I am moving down 3 units. Y equals x squared. Y equals a negative 2/3 x plus 4 squared. So take about 30 seconds, start looking to see what's different. So the first thing you should see is that negative, which again, it means that there is a reflection. This 2/3, because it is between 0 and 1, that means that it vertically shrunk by 2/3. This plus 1, because it is your horizontal shift, because it is plus, we're moving left 4 units. And because there is nothing out here, there's nothing here, there's no up or down. So there's no up or down for this one. So for C, the last one, original problem would be the square root of x. We're going to change it to 5 over 2 square root of x minus 2 and a plus 1. So I see 1, 2, 3 things going on there. So the first thing we see is this. It is greater than 1. So that means that this is vertically stretched by 5 over 2. This minus means, because it's inside, a minus means that it moves right 2 units. And this number here, because it's a plus, it means it moves up 1 unit. So looking at this, it should be good enough for you to work on problems 1, 2, 5, 6, 7, and 8. So using those 3 examples all together, you should be working on 1, 2, 5, 6, 7, and 8. They all come from examples 1 through example 3. So let's go ahead and move on to a different way that they could give it to you. So in example number 4, we're going to describe the transformation. But in this case, it totally looks a little bit different. They basically tell you that g of x is going to equal f of x minus 3 plus 2. So it just looks different. Not that it's going to be harder or anything like that. So basically what you do here is going to be the same things that we were looking for. Because it is grouped, a minus means that it moves to the right 3 units. And because this is a positive, it means that it moves up 2 units. So it's the same thing. The same thing. So let's look at one more. B, g of x equals negative f of x plus 5 minus 4. So negative f, that means that there is a reflection. The plus inside, because it's grouped, it means it moves left 5 units. The minus 4, because it's a negative, it means that it moves down 4 units. One more just to be safe. If they give you g of x equals negative x plus 2. So a problem like this, the negative, of course, it's the reflection. There's nothing inside, so there's no left or right. And then this, because it's a positive, it means up 2 units. So after doing that, you should be able to work on problem number 3 and number 4. So number 3 and number 4 are like example number 4. And there's just one more example that's going to be similar to 9, 10, and 11 of your assignment. So that was example 4. So let's look at example 5. In example 5, we're going to have to change words to a function showing all the transformations. So in this section, we're going to give you a big old paragraph of what's happening, and you're going to have to change it to an equation. So we're going to say the graph of f of x equals the square root of x is reflected over the x-axis vertically stretched by 3 shifted to the left 2 units and 5 units up. Let me just move this up. So change the words to a function showing all the transformations. So that should have an S. So they tell you, hey, the graph is f of x equals the square root of x. So it is reflected. So when you see the word reflected, you should be thinking, hey, I'm going to need a negative up in the front, right? When you see the word vertically stretched, you should know, hey, there's going to be a number after that. When you see moving left 2 units, I know I have to have a plus. And when I see moving up, I'm going to have an up, a plus also. So y equals, I'm going to just put it like this right now, square root of x. Because of the reflection, there has to be a negative. Because it is stretched by 3, there has to be a 3 there. Because the a, which is the stretch or the shrunk, and the reflection always has to go in the front. Now, the left part or the right part is what goes inside. So because it's left, I'm going to put a plus 2. Because it's an up 5, I'm going to put a plus 5. This here is my question, is my answer. So you're going to have to change words to equations. So if there is no left, right, there should be nothing inside. If there's no up, down, there should be nothing outside of the square root, the absolute value, whatever. Negatives and stretches and shrinks go up in the front. So this is enough for you to do problems 9 through 11. 9 through 11. So this is the lesson, and you should be able to work on the whole thing, 1 through 11, and then work on the review for the 2.1, 2.2 quiz. Make sure you have that and you work on it, because Friday, first thing we're going to do, and Thursday is work on the quiz and then do PSAT.